Hi again, this is Gene, robotics mentor from Team 714, Technology High School, Newark, New Jersey. Today I'm very excited to show you how to score a lot of points in the autonomous section of the REEFSCAPE game 2025 if your robot happens to have just one camera. You will be able to score good points for the game and also a ranking point, so you can advance to the finals. Now, what if your robot actually does not have a camera? At the end of the video, I will also show you how to pull off pretty much the same thing even without using a camera. Let's see what it's all about. So if you look at the rule book for the competition this year, 2025 game manual, the secret is hiding on page number 48, scoring. It's an auto ranking point. If all enabled robots leave, like start moving a little, and at least one coral is scored in auto. Doesn't matter where, just kind of score it on the reef, the lowest, the easiest point of the reef. This gives you a ranking point, which means it gets you closer to the finals, closer to the alliance selection, higher in the ranking. It's actually very easy to pull off. I'll show you how. Now, you might feel that you're missing a lot of context. What's going on here? This is probably because you haven't watched other videos on our channel. If so, please just go to our channel, it's called 714 Robotics, and maybe watch video number 13. This will get you all the context that you need for this one. If you're curious about simple ways to do object following, then you can also watch video 3V. But just to be sure you can watch video 13, this will get you in. Let's go back to scoring points for REEFSCAPE. Okay, so looks like the self-driving portion of the video is very relevant to REEFSCAPE. Let me show you.
Remove algae from.
How did the robot get exactly here? It was probably aligning itself or lining itself up with this April tag. That's to this point, because you cannot just drive that precisely with odometry.
The reef and place coral on.
How did this robot score the coral exactly on the reef? It was probably driving to this April tag and exactly with this April tag. How did they do it? Today, we will do exactly that. They were using cameras. And so we're back to my parking garage. Here on the wall, I have an April tag that's very close to the ground, right next to my first robotics backpack. And over there, right behind me, is a robot sitting. This robot actually does not see the tag on the wall because its camera is looking at me, while the tag is all the way there. What the robot has to do is has to drive towards me for 2 meters, then turn right, and then it will be able to see the tag and line itself up with it. Let's do it. If you're not familiar with Limelight, the green camera that's sitting on the robot is called Limelight. It's very, very easy to use. I highly recommend that you get one because you just need to plug it into your robot network. Then you connect to your robot network over Wi-Fi like this. I'm already connected. And then you just type, for example, Limelight or Limelight aiming, whichever way you want to call it, 5801 into your. See the video feed from it. Right now, the camera is configured to detect April tags, specifically April tags from the family 3611. So, and yeah, this person on the video feed is also me because the robot is looking at me. And right in front of this robot, it has already detected a tag, which is this tag on the wall. And let's take a look together at these numbers at the bottom of the screen. This green X is the origin. The tag is detected under it and slightly to the right. So the tag has a Y coordinate of -14. The tag has the X coordinate of 2.27. And the tag has the area size of 0.5%. 0.5. The whole area of the tag is taking 0.5% of the screen. Now, if I drive the robot to the right, the tag will go to the left. Now the tag has a negative y coordinate. Minus negative, 13 degrees. And these are actual degrees. The tag is going further negative, minus 19 degrees. This is the x coordinate of the tag. If I drive the robot to the right, because it's a swerve bot, now x is positive, because tag is located here on the positive side of the screen. But the y is still minus 16. The tag is still below the origin point. Finally, watch what happens with the size of the tag as I drive the robot closer to the tag. No, that's not closer. Closer. The size of the tag is increasing. Now it's 1.6. Let's drive even closer. The size of the tag is increasing again. The size is now 4.04. And as I drive closer and closer and closer, the tag is going bigger and bigger and bigger, 13%. So for example, a robot could just drive to the tag until the size of the tag is very big. And after this, maybe you can just program the robot to drive forward for 1 second slowly. And then you align yourself on the reef, even if your camera doesn't see the tag perfectly. Something like this. Let's write the code for it. Let's go to PyCharm, and we're going to start with wherever we left off from the last video. We already have these commands: swerve to point, go to point, aim to direction, and so on. Now we can go back to this GitHub page about autonomous driving, which we looked at previously in the last video. And what we can do is we can go to the fifth part, using vision cameras to navigate. First of all, we need a command to set the camera pipeline. What is a camera pipeline? If I go back to the camera website, you can tell the camera to detect only certain things. For example, you can say pipeline 0 is detection of April tags. Pipeline 1 is the detection of bright objects, like this one. Retroreflective, bright, shiny objects. Pipeline number 2, you can say, hey, this is detection of game pieces, detector. And so on. So you can have different pipelines doing different things. Pipeline 0 is for April tags. And what you can do is you can say, oh no, I only want April tag 4 and April tag 1 and April tag 9, and I don't want any other April tags. And this pipeline will only be doing this. So pipeline number 0. If you want your camera to switch between detecting game pieces in pipeline 1 and April tags in pipeline 0 and some other kinds of April tags in pipeline 3, then we need a command to set the pipeline right from the robot. So where did it go? The first command that we're going to take from here is setting of the pipeline. This is specifically for, no, this will work with both Limelight and Photon Vision. So if you have Photon Vision camera, that will work too. Opening commands and putting it into a file called setPipeline.py. Boom. This will set the vision pipeline for the camera. And we were supposed to put it into a file, command / set camera pipeline. Oh, I'm sorry, set camera pipeline. Let's rename this file. Refactor, rename. Set camera pipeline. Next step. Then we actually need the code that the robot can use to approach an object, to approach an April tag. All right? So this will be this command, follow object. Because if the camera sees the object, it can follow the object to approach it, or to at least point to it. This goes into a file called follow object.py, right? Yeah, this is where it was supposed to go. Finally, the last command is driving to a certain point on the field. No, this is not. The last command for vision is turning until you find an object. So looking for an object using a camera is another command. Robot will turn until it sees an object. And it goes into commands slash find object.py. Okay, commands, and we're gonna add a new file, find object.py into here. Adding. Okay, we have new commands here to use a camera. So now what we can do is we can add an auto in which robot will follow an object on the camera until the object is so big that the robot has to stop. This will be a command called follow object. Let's see what we need to create it. We need a camera, we need a drivetrain, we need the step size, and we talked about this in video 3V on this channel. And we need the decision about when to stop. Let's do it. All right, so we have added the commands to find objects and follow objects using the camera. The only trouble is we don't have the camera defined on this robot yet. We have a drive subsystem and we have a swerve module, but we don't have a camera. What do? We add the camera. So we go back to the vision and cameras examples in here, and apparently there is a step-by-step video on how to add cameras. You can click on it, you can watch it. It's on YouTube. Importantly, we need to get the code from that video, and it's here at this link. What we need to do is we have a limelight camera today, but if you have photon vision, that's the code for you. For limelight camera, we need to add this code into subsystems slash limelight camera. Let's do it. We go to subsystems and we're going to add a code file, limelight camera.py. Adding a limelight camera code here. Then we need to add this camera to our robot. So what we need to do is we need to go to pyproject.toml and make sure that the requires section has the PyNT core inside. Okay, let's go to the pyproject.toml in here. And let's see, the requires section is empty. We need to add PyNT core into there. Great. Next, inside of robot container.py, we actually need to add a camera, right where we add the drivetrain and other things. So if we go back to robot container.py, where we put all the robot subsystems, we have the drivetrain, we have the joystick, but let's also add the camera. Robot subsystems. The first subsystem we'll add is camera. And I think our camera is not called Limelight Pickup. It's called Limelight Aiming. You can name it whatever you want when you set up your own Limelight camera. But once you name it, you name it. It's called Limelight Aiming. Okay, finally, what else do we need to do? Yes, if you have a photon vision camera, then you do this, but we don't have photon vision camera. And I think that's all there is to it. We're not going to copy this example, we're going to do something more fun. Now that we have a camera, we can go back to this file, robotcontainer.py, this one. And let's take a look at what kind of autos we already have defined. We have a curved blue left and straight blue left from the last video, right? Curved blue left. So this is where they are. They are inside of configure autos function. These are the two autos that we have in here, straight blue left and curved blue left. Let's add another auto to approach tag. So we say, we're just going to do exactly what's done above. Save, chosen auto, add option, approach tag. And we need a function name for this, self dot Get approach tag command. You can name it in any way you want, but finally, we need to write this function in here, just like this autonomous straight blue left is written here. We need to write the function to approach the tag, to give us the command to approach the tag. So I'm starting to write it in here. First of all, we need to import find object, a follow object command from our commands. Where did it go? We go back to robot container. So we're gonna from commands dot follow object import follow object. Now this command is imported, we can use it. What we do next is we say follow tag. We're gonna call this command follow tag for the robot to get to the tag until the tag is big enough. If you look at the robot video right now, the tag is 4% of the screen. No, the tag is only 1% of the screen. How about we have the robot approach the tag and stop it when it's 8% of the screen? So we're going to create a follow tag command, follow object. Let's see, what do we need to provide? We need to provide the camera, the drivetrain, and how long will be each step in the object following. You can look at video 3V in this channel to understand what those steps are. So self.camera, self.drivetrain, which is called robot drive in here. Then we can provide the step in seconds. Okay, 0.33 sounds good to me. We don't even have to provide it. 0.33 is the default. And we need to provide the stopping condition. So we know when we should stop, right? We should stop, the robot should stop. Stop when equals stop when. We should stop when max size equals 8.0, 8% of the screen. And I think this should be it. Follow tag. This is the command that we will use in this auto. We're not going to attach anything to it unless we must. Let's see if it works. I'm deploying this code to the robot. The code is deployed. And if we go back to Elastic, we should now see three autos: approach tag, curved blue left, and straight blue left. We're going to choose the approach tag auto. And it's not a good idea to do this because we have not tested it at slow speed, right? So let's go back to the code and let's give it some much slower speed. How do we put the speed in here? We say speed equals 0.2. Now this is safe. Always start with a slow speed when you're testing new commands. Deploying it to the robot again. We can still choose the approach tag auto. And now we can go back to the driver station and enable the new autonomous. Okay, switching it into autonomous. Will it get to the tag? So it drove to the tag. It's looking at the tag, but it has not approached it directly. It's stopped. Let's take a look at the robot video. So it has stopped with the tag taking actually 11% of the screen, not 8. So it even overshot. And it's quite possible that it will lose sight of the tag when it approaches it very closely. So we need to add one last command to this auto to just maybe drive forward for split second and only then to stop, even if tag is not visible anymore. This way your robot compresses itself to the reef, pushes itself to the reef and approaches it fully. Let's do it. So we're going to go back to this approach tag command and we're going Remember we had this arcade drive command. This is just pure simple robot driving in commands. Let's use this. From commands dot arcade drive import arcade drive, and then in addition to follow tag command, we're going to add something else. We're going to say drive forward a bit, a little, is going to be arcade drive, and arcade drive has two parameters. It has the drive speed. Let's have a very, very slow drive speed, 0.15. And it has a turn speed or rotation speed. Where is it? Rotation speed. We don't need any rotation. Drivetrain equals self.robot drive. But this command is a little tricky. It needs to be used with a timeout. So I'm going to add, at the end of it, I'm going to say with timeout. And I'm going to say, hey, drive forward for only 0.3 seconds and then stop. Now we're done. Now we have a timeout. Let's connect them together. Command equals follow tag and then drive forward a little. And we're going to use this command. Return command. So the robot will now first follow tag, and then after this, it will drive forward a little with a drive speed of 0.15 and with a timeout of 0.3 seconds. Let's see if it fully approaches the wall or approaches the backpack and pushes onto it before stopping. Deploy the code to the robot and try again. One very important detail. Please re-choose the auto because after the deploy, it's all reset. We're choosing the approach tag auto and only then things will work. Now we're switching the robot and enabling. Let's see if it fully drives up to the wall now. Approaching the tag, and then it pushes forward for 0.3 seconds, and now it fully passes the wall because it pushed forward for 0.3 seconds after approaching the tag. Right. This is how you get to the reef in REEFSCAPE. So you can drop the coral onto it. Did you see what just happened? When we added this additional command to drive forward for 0.3 seconds, the robot had a chance to firmly push against the wall for a reliable coral drop. Now wait a minute, we actually want to create an autonomous routine for the robot to start from here, to drive all the way to here and drop the coral in the reef right here, don't we? Let's do it. First, we need to download the latest path planner that actually has, so we go to pathplanner.dev and then we say manual installs can be found here. Let's get the latest manual install that has the correct map. Looks like pathplanner 2025.1.1 is the one that has the map that we want. So, and a bunch of improvements, which are going to make it even better. I'm downloading the Path Planner Windows setup. Download completed. Click the link. And it says, hey, Windows protected your PC. No, run anyway. I'm going to click through the installation and let's see and open it. Okay, Path Planner installed. Let's use it. So these are the trajectories that we have created before. Now let's create another one. New path. Okay, let's call it blue coral drop auto 1. So in this trajectory, we want the robot to start from here We want it to go all the way to here. And let's add a few waypoints in between the start and the end. So I go to the start point, I say, hey, add the waypoint. Add a waypoint in here. Add another waypoint in here. And add another waypoint in here. So this is how we want the robot to drive. We want it to drive from the start point, and we want it to drive all the way to this red point at the end, from which it can hopefully see the location where it needs to drop the coral, the April tag in here. From here, we can use the camera approach to the April tag, push to it firmly, and then drop the coral. What do? We need to take the coordinate of the start point in here. And it should be minus 180 degrees, of course, precisely. And if we go back to the robot code that we have created, the get approach tag command, now we actually need to tell it, hey, you're starting from this point, from this position, where x is 8775 and y is 7262, and you're heading straight south, 180 degrees. Let's do it. So we can copy the example from the previous video that we made. It's called set start pose in here. So we can set the start pose to the x of, can you help me out? It's 8775, right? Y is going to be this one. And the heading degrees is 180, heading straight south. This is the south of the FRC field. Then, after the start pose, we need to create a trajectory for the robot to go all the way from the start pose to this red point, through all of these waypoints. This one, and finally to the end point. So let's do it. Again, we can use the previous example, previous video that's on the same channel, on this channel. We say from commands dot jerky trajectory, import jerky trajectory to create a trajectory. And then let's add a trajectory command. What do we need for this jerky trajectory command? We need the drivetrain. Okay, drivetrain equals self.robotDrive. We need to know the endpoint of the trajectory, and we also need to know the waypoints of the trajectory, which is the list of points to go through. And finally, probably a good idea to make it go with speed of 0.2, just to be safe the first time we do this. So what's the endpoint? The endpoint is this red point. I can click on it and see its coordinates. The x is this, the y is this, and the heading was really meant to be 0 degrees, straight north. So heading is 0 degrees. Waypoints. Waypoints, we're making a list. The list in Python is square brackets. And inside of this list, we can specify some waypoints. So the first waypoint, we can use the start point for this. It's this one. 8775, 7262, and 180 degrees. The second waypoint is obviously this point. 6503, 7, 6, whatever, and this kind of heading, and so on. Okay, I have all of them in here. Please make a mental note that this endpoint, I'm not putting it as an endpoint, as a waypoint, because I already have put it here as an endpoint. This is how it should be. Finally, it's time to connect all of these things together. Set the start pose, then run this trajectory. And then, once we're at the red point, the tag. In here, the April tag is clearly visible. So we can approach the tag and then just push forward a little to press firmly against the reef. Then I do not have a command in here, but if we had it, we should add a drop command, drop coral, but I don't have it in here. So what we should do is we should say, what do we have? We need to connect them all together. So first set start pose, and then trajectory, this one, right? And then follow tag, and then drive forward a little. And if we actually do have a command to drop coral, we should also say, and then drop coral, right? And this is everything that's needed to score this valuable ranking point in Autonomous this year in REEFSCAPE. Now, okay, you might ask, hey, I do not have the camera. Can I still score that ranking point? Yes, why not? So what you can do is you can start driving forward right from this orange point without using vision at all. Probably so let's just remove the command that uses the camera, follow tag. We're not going to follow any kind of tag. But we just probably need to drive forward not for 0.3 seconds, but for 1.3 seconds or even more. You have to calibrate it by the ear. Again, from here, we can remove the follow tag command, and hey, you can score this point in Autonomous without any camera at all. But it's not going to be as precise. You sometimes might miss. You have to practice a little bit more and maybe adjust some things. Thank you for watching. This is all you need to score this ranking point in Autonomous for REEFSCAPE, I think, by making sure to score the coral right during the Autonomous part of the game. Good luck!